anybody else out there in the world who is watching. This is a very special episode of Sparkle Muffins. You might notice this guy next to me. He's going to be, a little wave. Yay! If you don't know who he is, his name is Stroham back there. But I'm sure he'll introduce himself in a second. But thanks for tuning in. This is a very special episode. And would you please just introduce yourself to the world right now,
Yes,
sir?
my name is Mr. B, and I help Mr. Cookson with science and do a little bit of math tutoring here at Laurel Hill Elementary School.
And he's awesome. We just help some kids with the elements of the periodic table and balancing equations. He's really, really good with them all. It's really fun. I'm so glad you're in this room all the time and that you volunteered to do a special podcast. Now, Mr. B, I know it's almost our lunchtime.
It is.
You might not be that hungry, but it's tradition. And I see you have a muffin in front of you.
Yep.
Just to give a little cheer out to everybody watching this beautiful episode.
Cheers.
Here's our muffin. We have muffins. I'm going to take a bite.
Mm-hmm. Always got to enjoy a muffin.
Thank you to those robotics parents who sent in these blueberry muffins this morning, man. Woo! They are good. So, what's the topic today we're going to talk about?
Well, I know that you guys are talking about space.
We are.
Which is really awesome. And in space, one thing you see, obviously, when you look out your window, you see the moon, which is also a satellite.
What?
It's also called a satellite.
Look
and
up in the sky.
It goes around the Earth. Look at that.
Whoa.
So the moon
what's this thing right here?
That would be the sun.
Oh, okay. This is not to scale, though, right? The sun's a lot bigger than this.
That would be correct.
Okay.
The distance is not quite right, but you get the idea.
Yeah.
Small, medium, large. There you go.
So just for you out there that aren't sure, we are the Earth. We're on planet Earth. Most of us are from planet Earth. And what do? We go around. We revolve
around the sun.
Right?
There you go.
And as we revolve, what are we doing?
You're also rotating. Oh, look at that! That thing is rotating.
It for fun?
That's rotating. It's rotating around. That's really cool.
Fun. And the crazy thing, Mr. B, is as they go, the moon is also rotating around
the Earth. That's right.
This is crazy, kids.
And everybody knows. I think most everybody knows. Mm-hmm. Maybe not everybody knows, but the moon takes how long to go around the Earth?
Pop quiz time.
Pop quiz. I get the pop quiz. The science.
I'm going to guess about a month.
About a month is right.
Yes.
Now you have to remember that. And also, I think to remember today about this satellite, there's a long way between the Earth and the moon, like 270,000 miles. Let's say 250,000 miles just for reference. And it takes 1 month to go around the Earth. Okay?
That's a lot of gas in a car if you're driving 250,000 miles.
Yes, it is.
Most cars don't even make it that long.
Not that long.
Not that long.
Need to stop at a gas station in between.
Wow.
Yeah.
By the way, Mr. B, just out of curiosity for those kids out there, how long does it take the Earth to rotate around? I'll pop quiz you now.
Oh.
How long does it take the Earth to rotate one time around?
One time around is 1 day or 24 hours, which is also very interesting.
But for those kids out there who are exact, technically, isn't it 23 hours and 56 minutes?
Well, that's why you're the science teacher.
No, I don't know. I've seen both, but so 24 hours, 23 hours, 56 minutes, whatever it is. And one last one, then we'll get into satellites. How long does it take the Earth to go all the way around the sun?
Well, I think it takes a whole year.
Oh, wow.
Does it take a whole year to go around?
So you're 25 years old, so that means you've gone around the sun 25 times.
Maybe
Excellent.
26, possibly.
Oh, you're 26. Sorry. I didn't mean to make you feel old, but 26. All right, cool. So anyway, that's a little opening there for everybody who may not know that much about space. Sun huge. Earth, not huge. Not huge. And moon, not huge at all. Small, right. If you compare these three things.
But the moon is going around the Earth. That's around it goes. And that is what brings us to satellites, which are also something that are man-made. The moon is not man-made, and it's going around the Earth, and it's been there for millions of years.
Nobody made this moon?
Well, somebody did, but anyway, it wasn't man-made.
I mean, not man-made.
Not man-made. That's right. Not man-made. All right. Okay. So now there are certain things that are going around the Earth that are man-made. In fact, men put them up there, and those are called satellites also.
Oh, really? Sorry, I'm going to get this little satellite around our... it makes us look cooler. There we go. There we go. Okay. Now we feel like really like Joe Rogan. Yeah, it works. Oh yeah, it's working.
Okay.
Oh yeah,
it's working.
Yep.
So should we show them the? Well, let me just put this. We have time.
Oh yeah.
We'll talk about satellites in 3 different places around the Earth. One is very close, and you know what they call it? They call it low Earth orbit. Why? Because it's low and very close to the Earth. The second one is kind of, we'll call medium Earth orbit because it's there. And then the final one we'll talk about is 25,000 miles out, and it's called geostationary. And there's a special reason why it's called that. So, 3 different places where we like to put satellites, and we can talk about why we put them and what it means when they're either close or middle or far away.
Spectacular.
All right,
let's do it.
Let's do it.
I think
All right.
you built a beautiful model, didn't you?
I did bring a little model.
I'm going to move this thing over here. We're going to get real here. We got a model going on.
Where are we going to put the model?
You know what? Let's put the model right here in my hands. I'll hold it. How about that?
So let's talk about the low Earth, or some people in the business will call these LEOs. So, can we see this, Mr.
Let's see. I'll back up a little bit. We get that blue background.
Yeah, the blue background. And here's our little orbit. This is a piece of wire. And you see these little red things? Those are the satellites. Well, these guys are really close to the Earth, okay? And because they're close to the Earth, wow, they'll go around the Earth every 90 minutes. They are going around the Earth every 90 minutes.
That's like one movie. You watch a movie
about a movie, a half a movie, something like that. But they're very close. Maybe about 100 miles out, 100 or 200 miles out. Okay, wow. Those are called low Earth orbit. So why do you think we have satellites that are that close to the Earth?
Well, that close?
That close.
Because we need them.
We need them.
Constantly?
Yeah. So what we use those for that are that close, one thing we can use it for is taking pictures. You know about Google Earth, right? Okay. Google Earth has satellites that are taking pictures and storing them. That's one thing. We can use them for, like, farmers, if they want to see if their land is good, if they want to see, or maybe there was a fire or something and they want to take a picture of the fire and see how far it went. So those that are close to the Earth, we use to take pictures of. The other thing, more recently, if you've heard of Starlink, they put a lot of small satellites and they use them for communication, and they go around there. Okay, but we haven't used them in general in the past. That's a new thing, is to use them for communication.
So because they go around the Earth in
really
90
fast.
minutes,
in 90 minutes. That's
does
right.
that mean they're, how do I say that they can be used more often? Are they more useful, or are they
the biggest that you have to keep track? They're harder to keep track of a little bit,
okay.
And they cover the Earth more. The main advantage is that they're close. So if you have a radio, for instance, that's very close to the Earth, the sound waves can go there much faster. So your internet speeds can be faster, and also your picture can be better. I mean, it's just like if you have a regular camera. If you're up close to somebody and looking at it, boy, you get a really good picture. You go across the room or down the hall, you are. Yeah,
I'm not going to do that.
You don't want to do that. It might break the lens. No. Get that close. So, but far away, you can't take as good a picture. So that's what we use those things for. It's the low Earth orbit.
That's crazy.
And you can see them sometimes. Sometimes at dusk, if you look up and you see a bright light out there, and it's not flashing. If it's flashing, it's probably an airplane. But if you look up there and you see a bright light, and it's just moving fairly quick across the sky, that's going to be a low Earth orbit satellite. And just like the moon bounces the sun's rays off of it, you can see the moon. Well, that satellite bounces the sun's rays off it. You can see that tiny satellite flying across the sky, but only the ones that are really close.
So the satellite doesn't make its own light. It's the sunlight reflecting off the satellite.
That's correct.
Just like the moon.
Yes.
There you go.
There you go. All right. Should we talk about the next one?
Yeah, because those are close.
Those are really close.
What happened?
Now,
what ones are next? Yeah.
So the next ones are called MEO, or medium Earth orbit, middle Earth orbit. They're about 12,000 miles out. Like there. Yeah. So let's get another orbit.
Oh, yeah, let's do it.
Okay, let's get another one.
Let's do it. Oh boy.
So
here comes another
one. Here comes another one. Whoa, this one's big.
Model time.
Yeah.
Oh,
hey, can we see that?
Oh, yeah, we can.
Can we see that?
Oh, yeah, we can.
Yeah. So those things are going out there, and they're further out. Now, because they're further out, you know how long they take to go around the Earth?
Longer than 90 minutes.
That's correct. 12 hours. So twice a day, they've gone all the way around. See my little pipe cleaners here? Those are really satellites. Aren't those cute? You know what we put in middle Earth orbit, MEO? The GPS satellite. Wow, global positioning. That makes a big difference to us. Those satellites are really important because everybody who drives a car and uses Google Maps or Apple Maps, it's all using the GPS satellite.
Or MapQuest, if you
or MapQuest. Yes. anything that identifies you where you are on the Earth, global positioning satellite does that. And
have you ever been geocaching? Do you ever hear of it?
I've definitely heard of geocaching, and you use GPS to do that, right?
So if any geocache scouts out there, if you geocache and you're in the middle of the woods and you're looking for some kind of treasure you're looking for out there that somebody hid,
right?
You use the GPS coordinates
right.
to find out exactly in the middle of the woods where you are. Is that,
right. That is
correct.
Correct.
Right. That help you
Now,
out?
the interesting thing about GPS, so each orbit that Mr. Cook's holding up, each one has 4 satellites on it. What did I come up? 6 4s and 24. Should be 4 satellites on there, and there are 6 different orbits because there's 24 GPS satellites in action all the time. Why? So that everywhere around this globe, you've got some kind of coverage. You can see it. And you need at least 3 satellites to identify you in a flat area, 4 satellites to see your elevation. Okay, and also if you get under trees, behind mountains, you can mess up the satellites.
I'm either going to sound really smart right now, but you said you would need 3 satellites for your location as you stand on the Earth.
Yes.
Is that like similar to like an X, Y, and a Z axis, kind of like on a 3D printer? Like you have the flat, the X, the Y, and the Z. Like the X is the horizontal, the vertical, and the
kind of. It kind of is.
Okay.
Because
we can move on with that.
Yeah.
I'm just thinking like you said 3 satellites.
Yeah, because what the little receiver that you have, that geocache thing, all it's doing is it's figuring out how much time it takes its signal to get from the satellite back to you. And it knows, okay, for that amount of time, going at the speed of light, it's a certain distance. And because the satellite's there's a certain distance, that's the radius, it can draw a circle. So it knows that you're somewhere in that circle. Well, that's not good enough, right? It's not good enough. So we need another satellite where you're getting a distance, and it draws another circle, and now all of a sudden you have 2 intersection points. And the third satellite, you have another distance, and it draws another intersection, which picks out which of those 2 and said, boom, you are right there. That's why you need 3 satellites.
It's probably good in crime investigation, too, if you're looking for a criminal or somebody not did something wrong.
Right. If they
pinpoint their location.
Right.
But
you could do that.
I've seen it on like Law and Order shows and stuff. It's pretty cool. But that's amazing.
Yep. So that's what we use. Okay, so that's the middle.
What?
Okay.
That was a good arm workout too.
That was. You should probably put that down. I think we get the idea.
I'm getting a good workout here.
You are.
Okay.
Well, maybe that's what you get a twofer here.
All right.
The last orbit that we're going to talk about is what we call geosynchronous orbit. Right. Synchronous is important. So this is 25,000 miles out. And if you want to use this orbit, now this is way out, and because it's so far out, it is spinning around the globe at the same speed as the globe is spinning. So if this satellite is pointing at Indonesia and it's turning, no matter where it turns, it's always pointing at Indonesia. Okay? And that's why it's called geostationary orbit. Okay? It's always in the same thing, And those are very special spots, and all the countries get together, decide who gets what. But what do we use those for? We use those for like DirecTV, Sirius XM, okay? And they're always around the equator. So here's the equator on our cute little globe here. Let's find America on this cute little globe. Where is it? Here we are. So here's my satellite way out here. Here's America here. So this will tell you why, no matter where you are in the U.S., that any of your dish antennas face south because they're headed towards, they want to point towards that, okay? And if you're in the southern hemisphere, like, say, Brazil or Argentina, and you're looking at that satellite, all the dish antennas point north because they're going up, okay?
Wow.
So dish TV communications are out this far. And so you can see this satellite, because he's so far out, can see almost a third of the globe. So generally you take 3 of them, one over here and one way over here, and 3 of them can cover pretty much the whole globe except the poles. You can't see all the way down there. So those are the 3 different locations for satellites in general. There you go. Now you have it.
This all started with just talking about how this little guy,
the moon spins around here.
It's a satellite.
Yep.
And then we have all these functions of these other satellites. It's crazy.
Yeah, because some scientists said, what would happen if we got a satellite up there? What we could use for? And so they started doing it probably after I'm thinking after World War II, 40s, 50s-ish, something like that. Yeah, so they haven't been around long, but boy, have things changed in advance.
Yeah, really.
It's amazing how many things we rely on that we take for granted, our cell phones,
Yes.
our GPS, our dish TV, our Sirius XM, and I'm sure there's a lot of other things. And if satellites went away, we wouldn't have those.
There's just so much that we do every day that we don't even think about. Just being able to touch Google Maps and say, "Get me to the movie theater,"
That's right.
and like
And
we
there
just touch
go.
it, and we're there watching a movie, but we don't even know what's going on up there.
Yeah, I think most people don't know how to read maps anymore.
Like, yeah.
Yeah.
I remember my first time down in Virginia, I got lost with my friend, and we had
Yeah.
to use an atlas, a map. We
Yeah.
bought a map at the 7-Eleven, and we had
Yeah.
to find our way. Because my cell phone was very, very old.
Yeah.
It didn't have Google Maps on it, but yeah, things have gotten
Yeah.
better. So, kids, and adults, if you're interested out there, the rotation of the Earth, how we're going around the sun, all those little things you learn about in school, like 24 hours, yay! It all gets factored in with things like satellites.
And the other thing I
Speed.
wanted to mention
Yeah,
too, math and science are tied together.
Oh yeah.
Okay, math is what we.
Cheers to that.
Yeah,
Woo!
cheers to that.
Mm.
Math is what we use to explain the science that happens in the world around us. And you need more and more math. You need a lot of math to really understand how the satellite's going to move here. And so that's why I encourage people to learn your math, even if you start with multiplication, then you go to fractions, then you go to division. All that is a building block so that you can go to algebra and then calculus, and then you can figure out how these satellites are going to move. But you need math to do it.
You can build things that go into space, knowing all the timing of the rotation and speeds.
Right.
Yeah, it's pretty amazing. All the ties that math and science have. They're all connected. So I know kids in school, you learn this rotation, revolution, and satellites, but this is where it leads to, or one of the things it could lead to. Mr. B,
Yes.
a pleasure. There was a
Enjoyed
lot
it.
there. You made a model. You made a satellite model for us to look at.
Yeah.
Yeah, part
And
of
I got
a
a
muffin.
muffin.
You got a muffin
I got
out
a
of
sparkle
it.
muffin, yeah.
Beautiful. So much fun. If you listen to this whole episode, you rock. You just learned a lot. Kids, if you have any questions, come see this guy. Come see me. But actually, you know what? For a fun little challenge, maybe I'll give you a little prize. If you come up to me and say, all you got to say is the word satellite. And that will prove to us that you watched it. And maybe we'll give you a little prize if you come on in. I want to see who's listening. All right? All right. You guys have a great day. Mr. B, any final words? Or
I'm good.
All right.
This was
I'm
fun.
good
Thank
too.
you.
Bye-bye.